So we need to talk a little bit more about using elimination, and we're going to see this and we're going to immediately look at this and say, how do we do with fractions? Well, just understand that if you deal with fractions, you can multiply a equation by any number that you want, as long as you multiply everything by it, this equation by it. So I'm going to deal with this first equation, and we have these two fractions, and it might not seem obvious of what you multiply by, because we have a fraction here and a fraction here with two different denominators. So the question is, what do you multiply by? So here's another little side note. To clear any fractions in an equation, multiply by the least common denominator. The least common denominator. So the least common denominator in this would be between 2 and 3. That'd be a 6. So I'm going to multiply everything by 6. And again, since this is 6, we're multiplying the numerators. So that becomes 12 over 3x plus 6 over 2y equals 4. Now what multiplying by the least common denominator allows me to do, it allows these to all be divided evenly. So this becomes 4x plus 3y equals 4. Now it's a lot easier to deal with because these two equations are exactly the same. So I'm going to do the exact same thing with the second one. Between 4 and 8, the least common denominator is 8. But I need to make something really clear before I mess this up. I did not multiply this last term by the 6. You have to make sure you do that. So I got to multiply everything by the 6. So that's 24. So I got to multiply every term, and I got to make sure that I do that, otherwise this solution won't work out right. So I'm going to multiply by the least common denominator again. In this case, this is 8. So I get 8 over 4x, and if you get what these are before doing this, it's perfectly fine, minus 24 over 8y equals a negative 24 over 4. They're all divisible by the denominator now, so that becomes 2x minus 3y equals a negative 6. Now it didn't get us to our exact goal of trying to get the answers, but notice these are opposites here. So I can add these two fractions together. These become 6x. These eliminate. That's going to be equal to 18. Divide by 6, and I get x is equal to 3. So my x coordinate is 3. Now I'm going to use a different method. Rather than elimination, you can use these to find the other variable, but I'm going to plug it in for x here. Doesn't matter which equation you use either. I could use either one of these, but I'm going to use this first equation. So 2/3 times 3 plus 1/2 y equals 4. So 2/3 times 3, that's 6 over 3 plus 1/2 y equals 4. This becomes 2 plus a half of y equals 4. I'm going to minus 2. I'm going to get 1/2 y equals 2. Now to get rid of a half, you times by the reciprocal, which is 2. So I'm left with y equals 4. So my equation for this is 3 comma 4. So the solution of this, I should say, is 3 comma 4. Now I'm left with another problem. This looks nothing like what we had before. It looks vaguely familiar, but there's a few more things with this. So you've got to make sure of a couple things. When I write this first equation, hopefully you notice there's 2 different x terms. It has to be written in the same order. So again, this is a little side note that the x's and y's and constants have to match up, have to line up. So what does that mean? Well, notice how it goes x, y, constant. This it goes x, y, x, constant. So I gotta get this x to the other side. So I'm gonna subtract 2x to the other side. And I'm left with x minus 2y equals 5. So that's really what my equation should read. So the system that I'm dealing with is x minus 2y equals 5, 2x plus 3y equals negative 4. So here's my system. I need to solve this. I'm going to multiply this first equation by negative 2. So I'm left with negative 2x plus 4y equals negative 10. And then I'm left with 2x plus 3y equals negative 4. These eliminate, so I'm left with 7y equals negative 14. To solve this, I need to divide by 7, and I'm left with y equals negative 2. So my answer for this is, for a y coordinate, negative 2. Now I can plug this in if I want to. I can use the elimination process again. I'm going to plug it in right here for that y. So I have 2x plus 3 times negative 2 equals negative 4. So I have 2x minus 6 equals negative 4. I add 6. I have 2x equals 2. Divide by 2, and I get x is equal to 1. So my answer for that is 1 comma negative 2. So just quickly in summary, with these 3 methods we have graphing, which means you solve for y. So it looks like y equals mx plus b. And the solution is the point of intersection. We talk about substitution, which means you solve for a variable, and then after you solve for a variable you plug that in for variable in the other equation and solve. Then elimination, we want to match up the coefficients by matching up, meaning the opposites. And subtract the two equations to eliminate a variable. Now, in the next video, I'm going to talk specifically about how this applies to 3 variables and how you can use each one of these with 3 variables. But I'm going to mainly focus on this one for 3 variables because it's a little bit more straightforward. But it'll probably take me a video to explain how to do this, so make sure that you are prepared for this, because this is not something that is fairly straightforward, not straightforward like some of the stuff that we've done.